Hi, this is Sandhya Sabu. We are going to learn about the concepts of a data analytics lifecycle today. So first, as the introduction part, so we should know what is big data. Big data is nothing but a collection of large data sets that cannot be processed using traditional computing techniques. So for when we collect a numerous amount of data, then we can consider it as a big data. So if we collect data in terabytes or terabytes, it can be considered as big data. So what is the working of big data? So it has three main actions here. One is integration, management, and analysis. So integration is how the if for example as I said, if I'm going to if I've collected data in terabytes or sometimes even petabytes also I will be collecting data. So how these data are collected from sources and how it is processed. So these things undergoes integration. So next one is management. So how this amount of big data is managed or stored somewhere else in somewhere stored and how it is accessed. So next one is analysis. So analysis is something is the it is this is the final step, and here we will be acting on big data. Okay, so if for example if I'm going to create data visualizations like charts, graphs, and dashboards, this comes under the process called analysis. So next comes merits of big data. So first one is improved decision making. So here big data helps us to improve when you can manage and analyze your big data properly, you can discover patterns and unlock insights that improve and drive better operational and strategic decisions. Next one is increased agility and innovations. For example, since we have large collections of data, we have there is a possibility to identify different cases. Next one is better customer experiences. So combining and analyzing structured data sources together with unstructured ones provides you with more useful insights and for customers understanding personalization and ways to optimize experience to better meet consumer needs and expectations. So next one is continuous intelligence. So since we have properly maintained this big data, we can easily identify the different opportunities. And next, more efficient operations. Also, if you have given some process to be done, since the data is managed properly, we can easily carry out the process and improve risk management. So analyzing vast amount of data helps companies evaluate risk better, making it easier or to identify and monitor all potential threats. So next comes the topic called demerits of a big data. So what is the first thing is a lack of data, talent, and skills. So for example, for if a data scientists, data analysts, and data engineers are in short supply, and some of the highly sought uh, professionals are in IT industry, the lack of big data skills and experience is one of the primary barriers for realizing value from big data environment. Next one is speed of data growth. So since when it comes to big data, the data collection will be in large amount. That is, as I said, in petabytes or in terabytes, right? So we need to manage the data with proper care, and it should be stored and the data should be secured properly. So if if this data is growing rapidly, then it should be managed efficiently. Programs problems next is problems with data quality. So data quality directly impacts the quality of decision making, data analytics, and planning strategies. So having big data doesn't guarantee results unless the data is accurate, relevant, and properly organized for analysis. So next comes complaints, integration, complexity, and security concerns. So complaints, the violations is big data. Since big data have lots of sensitive data and information, it is tricky task to continuously ensure all data processing and storage to meet data privacy. Next one is integration complexity. So most companies work with data uh, across various systems and applications across the organization. Integrating disparate data sources and making data accessible for business users uh, will be complex in nature. So next last was security concerns. So as it will be considered harder to implement strategies and policies to protect those large set of data. So characteristics of big data and six, or we can say it as 6 V's of big data. So first one is volume. So as we know how we will be how we have named this data as big data. So big data, so as the name suggests itself, big data is nothing but large amount of data. So huge amount of data. So it depends upon the volume of data. So here for example, we have stated here in the year 2016, the estimated global mobile traffic was 6.2 exabytes per month. So 6.2 exabytes is nothing but 6.2 billion gigabytes. Okay, so this amount of large volume of data has been stored. So depends upon the amount of data. Okay, so first V is volume. Second V is velocity. Velocity is nothing but we know what is velocity. Velocity refers to the high speed of accumulation of data. So how, for example, if a data has been transferred, how efficiently the data transferred from source to destination. And for example, here we have stated as there are more than 3.5 billion searches for a day per day are made on Google. So all these things are the Google response. So and also Facebook users are increased 22% year by year. And third one is variety. So variety is how what type of data it is, whether it is a structured, unstructured, or semi-structured data. So it is also referred it refers to a heterogeneous sources. So what is structured, unstructured, and semi-structured? Structured data is the data is organized properly. It generally refers to the defined length and format of data. So semi-structured data is the data is based semi-organized data. It is generally in the form of data that do not form of the formal structure. For example, structured data can be some databases that you are managed properly, or for example the database of a student that is managed by a that is created by a tutor of that class. And semi-structured data is that something that we have for instantly we would have been noting some details in our tutor notebook, right? So that can be considered as semi-structured data. And unstructured data, for example, text, pictures, videos. For example, in our mobile, we will know so many videos will be there in the recent picture. So it will not. So that is called as unstructured data. So fourth V is veracity. Veracity refers to the inconsistencies and uncertainty in data. So big data is also variable because of the multitude of the data dimensions resulting from multiple disparate. And fifth V is value. So after having we have four values of four V's, right? So fifth V is value. So if the bulk of data has no value, then then you will not it will not be useful for any of us, right? So all the 5 V's are most important to us. So the last V is variability. So variability is how fast or available data, that extent is the structure of your data is changing. So for example, if you're eating an ice cream daily, the taste just keep changing, right? So this is what a variability means. So next one is big data ecosystem. So in big data ecosystems, we have data analysts, software engineers, database administrators, and data scientists. So here in data scientists, data scientists have he or she should have deep analytical talent. So what they do is they will be for using some technical or mathematics here to find out whether to sort out the problem. And both data analytics, data scientists, and software engineers are the plays the key roles in big data environment. So type of data analytics. So we have four types of data analytics. One is predictive, descriptive, prescriptive, and diagnostic. So this predictive is also known as forecast, is used in forecasting. And this predictive analysis is how can we make it happen? So this is what prescriptive sorry, predictive, right? So predictive deals with what will happen in the future. For example, we would have here that weather forecasting, right? So weather forecasting, they will be intimating us what will be going to happen in future. Okay, for example, whether it is going to rain, how much centimeter rain is going to become. So those things are called as predictive analytics. So predictive analytics deals with what will happen in the future. Next one is descriptive. So descriptive analytics deals with what happened in the past. So predictive is based is purely on future, and descriptive is purely on past. So whatever things happen in the past. So what are the things that we can do to manage to improve our product? So these can be descriptive. Next one is prescriptive. So prescriptive, how can we make it happen? So as I said, descriptive is purely on the past, right? So based on the past experience, based on the past improvement, based on the past result, what things can be done to improve? So this how to the way of thinking like this is called as prescriptive analytics. And last one is diagnostic analytics. It deals with why did it happen in the past. So it analyzes the reason. For example, it analyzes the reason for why the things had gone wrong in the past, like that. So these are the four types of data analytics that we have, right? So next and last comes the most major part of our presentation, data analytics life cycle. So we have 6 phases here. So see the diagram here. So the 6 phases is, first phase is objective, understanding the data cleaning and data transformation, data enhancement, data analytics, and data visualization. This is what the 6 phases of data analytics life cycle. So the first phase deals with business issue understanding as it objective, right? So it defines the objectives, it gathers information, and it clarifies what type of work to be done. Okay, the second phase, data understanding. So we will collect the initial data and we will identify the data requirements and we will check for the data availability, and we will explore data characteristics. And in third phase, we will be doing what we will be doing is data preparation. So we will have gather data from multiple sources, and we will present in a particular format. So next phase is exploratory stage analysis and modeling. So here what we will do is we will develop a methodology and we will build a model here. And in the fifth phase is validation. So in validation, we will be evaluating the results, determining the next steps what to be carried out, and the results are valid up to proceed to still sixth step, right? And if the results are invalid, we can if the results are carried out only from 1 to 4, then it is considered as invalid. And the last phase of the data analytics life cycle is data visualization and presentation. How we are going to present our data to the user, how we are going to craft it, how we are going to determine best method, which is the best method to present our data. So these are the 6 phases. So first phase, we will be in detail, we will be seeing it. First phase is data discovery and formation. So in data discovery, the evaluation and assessment should be undertaken during the initial phase to develop a basic hypothesis. So in the initial step itself, the data will be evaluated for its potential uses, from which a message we will be finding how this incoming information benefits our business. So as a data analyst, you will need to explore case studies using similar data analytics and examine current company trends. So once the completion of once the data evaluation is done, the team closes the stage with a hypothesis, and that will be tested using the data later. So this is the basic step for big data lifecycle analytics. So what are the key takeaways? So the data science team investigate and learns about the challenge. They create context and understanding. They learn about the data sources that will be required and available for the project. The team developers develops a preliminary hypothesis that can be later tested later. So we have come to the second phase, data preparation and processing. So data preparation processing involves gathering, sorting, processing, and purifying collected information to make sure it can be utilized by subsequent steps of analysis. An important element of this step is making sure all necessary information is readily accessible before moving ahead with processing it further. So when it comes to the data acquisition method, first one is data collection, drawing information from external sources, and data entry. The data entry refers to creating new points of information using either digital technologies or manual input. And third one is signal reception, accumulating data from digital devices like IoT devices and control systems. So an analytical sandbox is essential during the data preparation. So once executed, loaded, or altered, it resides securely inside the sandbox for later examination. So this phase of cycle does not need to take place in any particular order, right? And it can be repeated at later times as appropriate. So the third phase is design a model. So once we have defined the basic objectives. So it is our duty to gather large amount of data, whether it can be a format that is structured, unstructured, or semi-structured. It's time to create a new model to achieve the goal. So model planning is the name given to the stage of data analytics process. So we have three things here. One is ETL, ELT, and ETLT. E stands for extracts, T stands for transform, and L stands for load. So first is ETL. So extract, transform, and load converts the information before loading into a system using some set of business rules. And ELT, extract, then it will load, and finally it will transform. So here it loads, it loads a raw data into sandbox before transforming it. So last one is ETLT. It will first extract, transform, load, and then again it will transform. So it is the combination of the above two transformations. So this step involves teamwork to identify the approaches, techniques, and workflow to be used in the succeeding phase to develop the model. So the process of developing of a model begins with finding the relationship between data points to choose the essential variables and create a suitable data. So the fourth phase of data analytics life cycle is model building. So the data analytics professional should develop and operate the model they designed in the previous stage. So after this model designing, they have to build the model, right? So they should use efficient tools and methods such as decision trees, regression techniques, and neural networks to create and run the model. So it assists them in determining whether the tools they now have will be enough to execute the model or not. So what are the key takeaways is the team creates data sets for use in testing and training prediction. The team also examines if it presents tools if it present tools will serve for running the models, or if a model robust environment is required for model execution. So we will be using some open source tools like R, PLR, Octave, and Vega. So the fifth phase is result communication and publication. So here the project team is responsible for identifying the major conclusions of the analysis and calculating the business value associated with outcome and creating a narrative to summarize the communication and communicate the results to the stakeholders. And the sixth phase is measuring effectiveness. So to assess the effectiveness of the study, the data is transported from the sandbox to a live environment and it is checked whether it matches with the desired business aim. So if the findings meet the objectives, the reports and outcomes are finalized. And if the conclusion differs from the purpose stated in first phase, then you can go back in data analytics life cycle to any previous phases to adjust your input and get a different result. Thank you.